All right, we're looking at IP16, number 10. We're asked to graph this exponential function. Now, in order to graph this, we're going to use our starting value and multiplier relationships because these numbers are really nice, small, whole number, very easy to work with. So you do need to know this structure, and you do need to know that A is your starting value, or your initial value, same thing. So your starting value. And that B is your multiplier. It's the number that we are repeatedly multiplying. It's also can be your growth or your decay value. Multiplier. Okay, so we need to identify those from our equation. So our starting value here is the number that is out in front. It's a 2. Now be careful, don't try to multiply that together and make that 6. That won't work. This is an exponent which would have to be done before you can multiply. So our starting value is 2. And then our multiplier is going to be 3. This is the number that is being raised to the exponent. And once we know that, we can actually graph pretty accurately with just that information, because the starting value is also the y-intercept, and that's really important to know, aka the y-intercept. It's when the x value is 0. So I'll move it up just a smidge. Then I'll go ahead and set up a little x and y axis. I really don't need very much below the y-axis because an exponential function isn't going to be able to grow down below that. So I just really need an x and I need a y like this. Let's see, I want to have a scale that will let me fit my starting value. Move a little bit to the right, move a little bit to the left, and I'm going to get this curve. I'm going to get exponential growth. I know it's going to be growth because my multiplier is bigger than 1. So what I want to start doing is kind of plotting the points that I know. My starting value is 2, so that's going to be right here. That's going to be the point 0, 2. This will be dark enough, I think it'll read it well. So that's 0, 2. That's the starting value. Now my next value is going to be 3 times as tall. So I'm going to go 1 to the right, and then I'm going to be up at 6. So I'm going to be up at 1, now 6. And again, these numbers are multiplied by 3. I start at 2 and I multiply by 3 to get up to 6. Read that okay? Okay. Now I'm going to continue that process and I'm going to move another one to the right. So now I'll be up at 2, but I'm going to be 3 times higher than 6. I'm going to be up here at 18. I'm not even stressed too much about the scale because I just want to be aware that that is now at 2 to the right and I'm up at 18. 2 times 3 is 6, times 3 is 18. That is my growth. Okay. Now what we're going to do is we're going to reverse that process, and instead of multiplying by 3, I'm going to divide by 3. So 1 to the left, I'm actually now at 2 divided by 3. I'm at 2/3. So that's at -1, 2/3. And 2/3 divided by 3 is going to be then at 2/9. And if you don't like doing those fractions in your head, look, you can do 2 divided by 3. That's the decimal 0.666666667. It rounds at the end. That's 2/3. And then you can divide that number by 3. Take the previous answer divided by 3. And look, I'm going to get this 0.2222222, which is the fraction. Math, make it a fraction. It is 2/9. Okay. But the point is, it's really low. Like, it's just going to get smaller and smaller. I'm at -2. Now I'm at 2/9 divided by 3. So my curve is going to, start here, go up way high, and then shoot down. And it's never going to go below the x-axis because what I'm doing is I'm dividing by 3. So I'm always going to have some value. I'm never going to get down to 0. In fact, this entire pink curve is always going to stay above the x-axis. And the fact that that stays above the axis is actually giving us this concept of an asymptote. It's one of the things that we have to identify here. We're going to identify our domain. We're going to identify our range. And then we'll also, I'll put it here, give the equation for the asymptote. Okay, it's the name of the line that the curve will approach. And you can see visually it's the x-axis. All right, our domain has to do with the fact that there are arrows on both ends, and they are going forever to the left, forever to the right. It's going both directions, so our domain is x is all real numbers. Now, our range is not really all real numbers because we are going up for sure, but we don't go infinitely down, right? We're kind of turned here at the x-axis, and we stay above the x-axis. So for our range, it will start with our, y is all real numbers. Y is the set of the real numbers, but it stays above the x-axis. Well, on the x-axis, that y value is 0, so all your y values are going to stay above 0. And again, they never get down to 0 because we're continually dividing by 3, this way multiplying by 3, this way dividing by 3. We always have something. Okay, the asymptote is the name of the line that the curve approaches. Well, we already mentioned it's the x-axis. It's going to get down and hug that. Well, the x-axis is a horizontal line. The structure of horizontal lines is that they are y equals a number because they go through the y-axis. The y value is going to stay consistent. And we just need to identify that point. We already mentioned that it's 0, so that's the name of our asymptote, y equals 0. So you can graph y equals 2 times 3 to the x really quickly, knowing the starting value here at 2, tripling to find points going this way, dividing by 3 points to go that way, and you get that nice exponential curve. Domain, range, and asymptote. Here's all that information. Hope this is helpful. Message me anytime with questions.